Metaphysics. Our first speaker today is Dawid. He's professor of philosophy at Stockholm University and is going to talk about common core dualities and classical limits. Thank you very much for having accepted our invitation. And please, thank you.
Thank you. Yes, this is joint work with Guy Franzmann. And what I want to do is I want to push back a little bit against the position on the way one can be a realist about string theory that is fairly popular in this room also, I think. And I will try to give some reasons that a different perspective on the issue might have advantages. So just to start, a very short sketch of what string dualities are, because string dualities will play the central role in those considerations. In string theory, there is an extensive web of dualities that is posited at the level of conjectures. And this structure of dualities is a core feature of string theory. And we will see why it is such an important feature of string theory a little later. So the upshot is that dual theories are empirically equivalent to each other, but they differ in fundamental characteristics, at least if the type of string theory or the string theory is written or spelled out in perturbative form. Dualities are properties of the full string theory, however, so they are not placed at the perturbative level, and they are means of reaching beyond the perturbative regime. And in this talk, we will assume that those duality relations are exact, which is very commonly assumed, but not by everyone. There is a certain amount of debate on whether one can have another perspective on that. So there are a number of dualities. Just to give you some of them, there is, for example, T-duality that links one type of string theory to a different type of string theory by inverting a compact radius of an extra dimension and exchanging transversal momenta and winding mode on that compact dimension. This is T-duality. Then there is S-duality that links one type of string theory to a different type with an inverted value of the string coupling. And these two dualities connect the 5 types of string theory that can be formulated along this, what I drew here. So you have various duality relations. Then here you have M theory, and in a sense there is a duality also between types of string theory and M theory. So there is also a kind of manual that connects those two. So what is important, or what will be important, is that M theory is not, it's not quite accurate to say that M theory is the more fundamental theory than the types of string theory. It is itself a part of the web of duality. Another duality is gauge-gravity duality that has been spelled out or can be represented in a specific context where you have a string theory on an ADS space, and this string theory on anti-de Sitter space is dual to a conformal field theory on the boundary of that space. So there is a d-dimensional string theory on ADS space and a d-1 dimensional conformal field theory on the boundary. ADS CFT is a well-established conjecture. It might be a special case of general gauge-gravity duality, but unfortunately, one hasn't been able to achieve an understanding of how this would play out on the Sitter space. So it is not clear whether, and if so, how a general gauge-gravity duality plays out. But of course, it would be very interesting to have one, and it's difficult to understand ADS-CFT correspondence in some way without assuming that there is something of that kind around. Now, okay, so the problem now is, in light of those duality relations, how can one be, or can one be at all, a realist about string theory? And the problem is that normally, if I enter this consideration with the expectations of a traditional ontological scientific realist, I would want to think that as a scientific realist, I'm able to endorse a specific ontology that characterizes that theory. Even if I'm a structural realist, and I think about structural realists in terms of fundamental realism, which not everyone does, so some structural realists actually are effective realists, which then has a different story. But if I want to be a fundamental structural realist, then there is something similar going on. I want to specify and identify structural characteristics of the theory that are approximately true. And this, at the face of it, does not seem to work in the context of string dualities, because those dual theories are so fundamentally and radically different in what seems to be their ontologies. They have different dimensions of fundamental objects, different gauge symmetry, different background space dimension, geometry, and so on. And yes, and I was among those who quite early on, when thinking about philosophy of string theory, has argued that on that basis, therefore, this would. Now, there has been another perspective or a suggestion as to how to deal with that has been put forward by a number of people with slightly different emphasis. Let's say by Dean Rickles, by Nick and Chris, and by DeHaro and Butterfield. And they propose, the common core of what they propose would be the following: only the common core that is shared by all dual theories is real. While what is part of the story of the individual duals and differs from one dual to the other is not. And if one wants to think about an analogy with this that makes this perspective plausible, we might think about different coordinate systems to characterize a physical situation. Or you might also think about gauge. And you might say that, of course, if I would take all those coordinate systems as an individual theory, I would kind of overcharge the theory. It's not right to do that. Those coordinates don't merit realist commitment, so I should leave them aside. And only what's common to all those coordinate choices is real. And this analogy, this intuitive analogy, will play a little role later on when we think about the alternative approach and the possible problems of that. Now, the specifics of common core have been spelled out differently by different authors. We want to focus on the DeHaro-Butterfield formulation. They give a very general account of what they take to be the common core of a theory, which of course is the crucial question then. Okay, what exactly do you mean by the common core? And DeHaro-Butterfield choose one may say, fairly formal approach to this. They characterize a theory as something that describes a system by ascribing to it numerically measurable quantities, Q, the states of the system, and so each state then would be the list of values for those quantities, and the dynamics D that specifies, to say, the allowed sequences of those states. And now these dual theories are empirically equivalent, and therefore they share the same quantities, the same states, and the same dynamics. So that's what they have in common, they argue. And this triple T of Q, S, and D is the core theory that deserves realist commitment. And in their terminology, that's the theory, and the duals they call models. And I will adopt that language in order to be in line with what they're saying. So the models of the core theory are the types of string theory, for example. And the exact structure of those types then doesn't merit realist commitment. Now, we agree with de Haro-Butterfield and generally with exponents of common core realism, that first, that it should be possible to be realist about string theory, and second, that realism cannot be based on the ontology of a specific dual. And we also think that the de Haro-Butterfield proposal itself is a consistent proposal. So it is a way you can set up a realist commitment. You can say, so that's what I take to be the common core, and that's what I want to be a realist about. What we argue against is the fruitfulness of that perspective on two accounts. The first is that, on our understanding, the common core is too weak to allow for extracting novel predictions from the theories, what they call the theory, so the common core theory's structure, and that this has repercussions for the role of scientific realism in such an analysis. And second, the common core realism does not account for a crucial message from the web of dualities, and that message is that there is more than one classical limit. And we take that to be one of the most important messages one gets from string theory. Okay. So why is it a problem that the common core does not function as a basis for prediction itself? So first, what one can say is that there is no basis for extracting future dynamics from structural characteristics at the level of the core theory, since no sufficient amount of structural characteristics actually are spelled out, right? In order to do calculations, to make predictions, to specify the constraints on the spectrum of future experimental empirical results, one needs to go to one of the duals. And one needs to do the calculation in one of those duals. Therefore, we cannot understand the theory as the full basis for making calculations, let's say. And if it happened, of course, the situation is that string theory now is a highly incomplete and incompletely understood theory, so there may be lots of things going on. But if some new ways of calculating the theory came up along different lines than using the known dual theories, it is most plausible to think that these calculations would then be understood as having found a new dual, right? You would identify a new dual theory if you identify structure that characterizes the theory, and you would reach that dual from the duals we have. Now, the problem is that it is a central motivation for scientific realism to explain why scientific prediction is successful. And if prediction depends entirely on models, then the scientific realist commitment that is reduced to the theory itself, to the common core theory, loses the NMA type argument for scientific realism. Which means that since we need to go to the model to check whether a given future dynamics can or cannot be real, the predictive success cannot be explained by the common core itself. It has to be explained by the model or even by the set of models, so by the web of dualities, given that it may not be sufficient just to look at one of the duals to do the calculation. So since the models are not considered real, however, real scientific realism does not provide a basis for explaining predictive success. That is the first argument, the first problem we identified. Now, one can make a rejoinder to this and say, okay, but if we think about coordinates, we seem to be in a quite similar situation, right? So we, in order to spell out predictions regarding a certain, based on a certain theory, we use coordinates and we write equation of motion in terms of those coordinates, and we specify initial conditions on that basis maybe. But we don't take the coordinates to be real, right? So there seems to be something comparable going on at that level. So we seem to feel fine with such a situation when it comes to coordinate choice. And our point is that this is not quite the same issue as the issue we face in the case of string theory. And the reason why it is different is there is, we think, a subtlety about realist commitment in such a context where we think coordinate independently about a theory. So if we think coordinate independently about a theory, and we are realists about that theory, we think in terms of identifying observable objects in the world and then applying the theory to those objects. So if we think what we are actually realists about, we are not just realists about the coordinate independent formulation of the theory, but we are realists about, if you want, the coordinate independent formulation, but then also about the objects that let's say can be fitted into the theory and that can be identified in the world. So we have a residuum of pointing into the world and say that's where we want to use the theory, and that's what we are realists about. Now, in the case of common core theory, we would need to do something similar. We would need to add something along the lines of doing that. But in fundamental string theory, we lack this naive component of observer objects spatially related to each other, of anything that we can point at, so to say. So there is no, in a sense, there is no external world that can help us to reify theory. So all we have is the theory at this fundamental level, and the theory at this fundamental level on its own, without any help from our embedding it someplace else, needs to tell us the full story. Which means that we cannot be realists about common core plus object somehow. We only have the theory. And therefore, we need to characterize the theory in a way that on its own gives us the basis for making predictions. And therefore, we argue, in the context of string theory, it is more instructive and closer to the, let's say, to the spirit of realist commitment to take the entire apparatus of the theory that includes dual models, the relation between them and all that, to take that to be reifiable, to take that to be what we should be committed to when we are realists about string theory. So we need the level of models to do that, and if we don't include the level of models, we miss something essential. Now, there is a second issue that speaks against ignoring the models when expressing realist commitment. And this second issue has to do with the web of dualities itself. The web of dualities, as we said already, is a crucial characteristic of string theory. And the web of dualities itself cannot be read off the common core. It's not in a straightforward way implied by spelling out the common core. The other way around works, of course. We can move to the common core from the duals. But we cannot say, okay, this is the common core, and what follows is that there are that and that and that dual formulation. So only once one has a model, is it possible to infer duality relations. And then the duality relations are important. The individual duals are important because each individual dual represents an individual classical limit of the theory. So the duality structure determines the theory's classical limit. And therefore it is a crucial characteristic of the theory. And if we want to be realists about the theory, we should be realists about that. We should be realists about that aspect. Now, what does this mean? We think what it means is that we need to give a different role to ontology. Ontology in the common core, from the common core perspective, is an essential part of realist commitment. As a realist, one is committed to the ontology, and one needs to find a place where there is an ontology that we can be committed to, and that's in the common core. On our view, this is not the most helpful way, let's put it that way, to think about realist commitment in this context. However, ontology does play an important role in understanding the theory. And it plays an important role because ontologies represent the way in which our fundamental theory is linked to what we observe. So it plays a role as indicating the near classical entry point we might have to that theory. And of course we know whatever, even thinking about this in terms of possible worlds and our observations, we need a neoclassical entry point to understand what an experiment is, what an observation is. So the ontology tells us, or the set of ontologies of string theory tells us, in some sense, in which ways we can observe the world if that string theory if that theory is viable. So the situation is that these dualities lead from one neoclassical case to a deeply quantum one, typically. So, for example, and most straightforwardly in the case of S-duality, we have a weak coupling, a type of string theory with a weak coupling constant that, in a sense, you could call neoclassical, and that is linked to a strong coupling constant in the dual theory, so a deeply quantum situation. In T-duality, it leads from a situation where velocity can be, where you have a large extra dimension, so velocity can be changed nearly continuously in that transversal dimension, and this is linked to a situation where the allowed transversal momenta are very far apart. It's kind of, in a sense, a deep quantum situation. In ADS-CFT, we link a situation where curvature is small to a strongly coupled conformal theory or a weakly coupled conformal theory to a situation where curvature is high. So once again, we have a similar structure. So what we have here is that dualities establish these several very different classical limits of string theory. So the duality leads from one near-classical limit, if we start there, to deeply quantum, and then the dual theory would have some, let's say, effective free parameter, in the effective description, for example, the string coupling constant, and we can change that parameter value to small values, and then we have a weakly coupled new type string theory. So we have one model close to the classical limit and the dual one very far away, and altogether our manipulations can give us the spectrum of the dual theory. And each of those neoclassical limits is pointed at by an ontology. So the ontology links our intuitive observational perspective to the full theory by pointing at the way in which the latter assumes features that can be related to our intuitions about objects in space and time. Now, in the deep quantum regime, none of the concepts deployed for characterizing the neoclassical limits keep their fundamental significance. So to apply these ontology to a deep quantum regime is not awfully helpful in any case. If we talk about an ontology in the way that it points at a neoclassical limit. So one might also think about the way our specification of ontology is influenced by that. And I don't want to go into that, and I don't have a very clear story to tell about this, but the idea would be that assigning this role to ontology specifies in those debates of what is a reasonable way of spelling out the ontology of a theory, it might lead to preferring one over the other of those suggestions on that basis, if you say that's what you want to get from an ontology. And the point now is that these ontologies of the duals that point at neoclassical limits are decoupled from realist commitment with respect to the full theory. It's a different thing. We ask different questions. If we spell out the ontology of a type of string theory, then we understand how the theory would link to an effective theory if we actually lived close to that classical limit. So we would get, for example, the right gauge structure that we would find in an effective theory that links there, or the correct spectrum of particles, or right brane structure if you think about effective theories that are based on brane dynamics or kind of assumptions of large extra dimensions and so on. This is related but different from the issue related to, but different from the issue of effective theories. At low energy, so far we have talked about the distinction between deep quantum and neoclassical. So basically it's a low coupling, strong coupling distinction, let's say. Another way of making a distinction is to specify a certain energy and characterize a theory below a certain energy scale. So that would be thinking about the situation in terms of effective theories. Now, and at low energy, then the fundamental theory can be described by a tower of effective theories at low energies. And that would then link to one of those neoclassical limits if we want to characterize a situation, let's say, where perturbation theory applies and where we characterize the situation by a low energy quantum field theory, for example. So those theories then, those low energy theories are spatio-temporal, which means that some of the intuitions about the world that we may have are retained in the effective theories that are then lost at the fundamental level. So roughly one might call that, frame that in terms of emergence, right? Now, an effective theory tends to have, let's say, one classical limit, not always, but there can be situations like that. And if that's the case, the ontology has a chance to characterize the effective theory in an unequivocal way. So then we have one ontology only, and this ontology then, in a sense, characterizes the effective theory. So in those cases, in such contexts of effective theories, there is a connection between the ontology and scientific realism, and that may be the reason why we naturally might expect that there is this connection. Ontology and realist commitment therefore get closer to each other at the effective level, and they may appear wedded to each other at the effective level. Which means that at the level of effective theories, realist commitment can be in line with spelling out an ontology, but realist commitment at the fundamental level is quite different from that. That would be the idea. So the proposal would be to split ontology from scientific realism and to think about it as conceptualization concepts that characterize, that address different questions. Ontology is about the way our observational perspective is linked to the theory. Spelling out the ontology then starts from an observational perspective in a way, and the ontology is linked to a specific neoclassical limit. And then the ontology we are actually committed to would depend on the neoclassical limit our system happens to be in. So we happen to be in this world, let's say. Realism, on the other hand, is about commitments to the theories, the full theories, approximate truth. Which means that spelling out the real theory does not start from observation, but really needs to explain observation in some sense by having a corner where observation is possible, let's say. Realism, therefore, neither selects one dual nor reduces to a common core on that understanding, but it takes the full theory as specified by the individual types or models of string theory as its basis for realist commitment, and it does not insist on any one real ontology. So to conclude, in order to fully grasp what a correct fundamental theory amounts to, we need to understand two different things. First, we need to understand what the theory per se amounts to. And second, we need to understand how the theory relates to the specific environment we observe and we derive our intuitions from. The first question is observer independent, and the second is not. And our claim is that realism addresses the first point, while ontology addresses the second. And in a low-energy effective theory, those two issues may seem to be closely related or linked to each other, but in fundamental theory, string theory, we argue, they fall apart. Thank you.
Thank you very much. We now have a comment by
So thank you very much, Richard. It was extremely interesting, and it's a very new topic for me, but I got the chance to go through the literature a little bit, so it was very interesting to hear your talk and to read your slides. So what I find particularly interesting about this project and about the presentation is this idea of trying to go beyond this common core strategy, which has provided a very somehow clear-cut and a nice picture of how to deal with this issue of dualities, but that in a sense, in a way, may look a bit too formal, and that indeed somehow the details must play some role, and so that by looking at specific dualities, we may find some nuances and some differences which are not captured by this general broad strategy. So I take as the main take-home message the idea that indeed, once we go to specific applications and to specific dualities, it looks as if just sticking to this common core theory somehow does not provide us the proper context. And so I would just like to ask some broad questions to somehow get a little bit more of a sense of what is going on in this general project. So first of all, although I do agree that this common core strategy is quite general and quite formal, if we take this as a sort of background, and so if we take specific theories as actually duals as somehow a subsector of a broader fundamental string theory, so dualities as properties of this more fundamental string theory, I was wondering where would you draw the line between the connections between this model and being an instantiation of dualities versus being an instantiation of symmetries? Whether you could, so what's your standpoint on this? And then I would say that there are three main aspects I'd like to hear a bit more about. The first one, maybe the best way to capture is it in terms of scale. So you've been speaking about the fact that it looks as if by looking at these models, these dual models leads to different classical limits. But if we buy the idea that these dual models are to be conceived as a subset of this more encompassing fundamental or more fundamental string theory, it looks as if these different classical limits, as you were discussing in slide 18, appear within different sector of this broader theory. So I was wondering whether you could expand a bit on why we should bother about the fact that we indeed have different kind of classical limits. The second question, which is probably the one that interests me the most, is the one I would probably put under the idea of ontology. So again, your point is that dual models or theories, I'm not sure what is the best way to capture the relationship between them, provides different ontological commitments, and you were discussing, for instance, about dimensionality or different gauge symmetries and so on. But the more you go through your presentation, the more I feel that the ontology you have in mind is quite thin, quite slim, so almost, I don't know whether that is the proper way to characterize it, almost operational, but like linked to the idea of something that is pointed throughout a certain measurement apparatus. And indeed, you said that ontology is what provides a link between what we observe and the more fundamental theory. So I was wondering, even not considering the fact that dual models seem to provide different ontological commitments, how do you define ontological commitments even within one of the two duals? So how do you define ontology in the first place? And in particular, provided that there seems to be some controversy on how you should understand the ontology even of one of the two duals, then I was wondering how this has an impact on the applicability and the use of the no-miracle argument that you were talking about. Because as long as you don't characterize sufficiently clearly what the ontology is, I don't see why you cannot add some, I don't know, spurious ideology that somehow may play the structural role that is meant to lead from the different dual theories. So even if the common core theory is not useful per se on this, from this standpoint, we may conceive that additional structural elements which connects the duals as something that can be just regarded as a sort of additional ideology, which should not be regarded as ontologically significant. And this is conducive to the third point I would like to hear a bit more about, which I would generally call heuristics, of course, but it's still related to the second point, sorry. So I think you eventually talked about the fact that one limitation that arises from the common core theory is that you basically, if I got it right, lose track of the web of dualities and among these possible models. So there seems to be some kind of underlying assumption that we need to guarantee the existence of these mappings. And while I can understand the import of this strategy, if in the context of heuristics and also in the context of theory building, especially if, as is the case, there are some dualities which are meant to map strongly coupled with weakly coupled models, and so that we know that we can go through the weakly coupled theory in order to get some calculational advantages, say. But I was wondering, once our focus is again ontology, why should we rule out the usefulness of the common core strategy if the focus is not this theory building aspect, but is more concerned with this view about ontology? So
Okay.
that's it.
Yes, thank you very much. Those are all really excellent questions. The first question was about comparing dualities and symmetries on that count. And I would say the most general response that plays out at this very general, that covers all kinds of types of symmetry, let's say, is that there is this, the dualities have this, this specific character of spelling out the spectrum of neoclassical limits. So it's a very peculiar role dualities play compared to other symmetries, where that's not the case. So that makes them, in a sense, more significant, even if even when we move towards talking about gauge symmetry. That's what, I mean. Of course, if you have a symmetry, a physical symmetry that is embedded in some way that makes the symmetry observable, then it's in other respects also a quite different situation. If you just look at gauge symmetries, I think this difference is crucial for understanding the additional role of dualities in spelling out the implications of the theory. So in the case of gauge symmetries, of course, there is also gauge symmetry also can play a very important role in understanding the structure of the theory. But changing the gauge, for example, kind of does not give us any new physical input. While moving from one of the duals to the other tells us about what a different neoclassical limit looks like. So I think that would be, in a nutshell, the most important difference, I think. So why are those different classical limits important? And I take it that the focus of your question was why is this important, given that we only sit in one, so to say. There are two levels at which one can answer that question. Both answers are related to the fundamental structure of string theory. So in string theory, choosing a ground state, so the specification of a coupling constant or of the size of an extra dimension and so on, this is part of the dynamics. It is so each of those, the spectra of those parameter values depend on, sets of those parameter values depend on choosing a specific ground state of the theory, and even though no one understands how this works and no one understands the full theory, what one has to assume is that there is a dynamics of the full theory that selects this. And this is a quantum process, so there is a stochastic element in doing that. So if we want to be realists about the full theory, we want to say we are not just focusing on where we ended up in this world, but we want to grasp what the full world would look like if string theory was a viable theory. Then we need to grasp this overall picture, and so we need to understand what all the places the world could have ended up in. So that's one level of responding to it. The second level would be that if one adds a multiverse component to this, so if one joins string theory and inflationary cosmology, you have this multiverse structure, and you have specific universes in that multiverse. Each of that universe on its own plays out this stochastic process. So each universe on its own selects one of those vacua. So if we think about the world in terms of a multiverse, then all those vacua are realized somewhere in the multiverse. So then it makes the situation, so to say, more actual. Yes. So that would be the second question. The third question: what is the ontology on our account? And you're absolutely right that I didn't say next to anything about that in this talk. I would have two answers, and one reason why I didn't say that much about it is that I'm not entirely sure what the right answer is there. Generally, what one might say is that on this account, the ontology of one of the types of string theory would play out along the lines of an ontology of an effective theory. So if you think about an effective theory, you would not the coupling constants. They might be energy dependent, of course, but the coupling constant would be a fundamental parameter value. Yeah? So you could just, they are not part of the dynamics, but you can specify them. You can choose them in order to fit them to the observation. And in a similar, so if you talk about an effective theory, there are two ways of thinking about the dynamics. You might think about the dynamics in terms of our perspectives on the world, or you might try to focus on the full theory, on the full effective theory. And of course, in that, so that plays out along the lines of discussing ontology in terms of those effective quantum field theories. And there are different accounts of what you want to choose the dynamics. And in principle, the simple answer would be that the ontology then would correspond to the ontology of that type of string theory that is close to that represents the neoclassical limit we sit in. And then the apparatus would play out along the lines of discussing ontology in a quantum field theory. It may, however, that may not be the correct answer or the most helpful answer, because as I already suggested a little bit before, now we have a different perspective on ontology. And so ontology plays a different role. So it may be more plausible than before to actually emphasize the perturbative formulation of the theory, and to focus with the ontology on acknowledging the low energy characteristics of that theory. So I'm not sure whether that makes sense or whether, but it may be more plausible to think about the situation in terms of excitations, for example, in this perturbative limit, than it would be if you look at the full theory and rightfully say, but this is not the full ontology of that theory. If we just focus on linking to our observations, it may be more plausible to go down that road. But that's very tentative, so I don't know whether it actually makes sense. Then the last question was about the heuristics of finding dualities. And yes, this is, one important point about finding dualities is that we don't know that they exist before we find them, right? So even if we have models to establish a a duality relation amounts to identifying the dual and establishing the manual. So before that happens, so there may be other duality relations within the framework of the theory that no one has thought about. So it is not and this is part of this general situation that string theory, there is no even remotely complete understanding of the theory. So there are inroads into the theory, and identifying those dualities are part of that, which means that, I mean, this is maybe one more reason to say that identifying those ontologies of the dual theory is relevant for finding the correct neoclassical limit. But it's not, as it stands, there is not even the possibility to spell out the full set of dual theories, and therefore maybe also not the full set of ontologies that you might assign to those theories. Yes, so that's I think.
Thank you, Richard. This was very nice. I have like a curiosity and a puzzle. So the curiosity is that it seems to me that at least the classical limit problem, let's say, that you mentioned, and the observable, the definability of observables in a gravitational theory that you mentioned, sort of, they seem to me to sort of, even though you sort of present them as separate things, they seem to me to be very much connected. So if I can fix a classical limit out of my whatever fundamental theory, then I can also define observation, and then I can solve the problem of not being able to define observables in gravity. So like I was curious sort of how the two problems are supposed to be related. The puzzle that I had is that I'm not entirely sure why you take the common core to not be able to involve classical limits. In particular, as far as I understand what Sebastian and Jeremy do, first of all, they seem pretty fine with taking the common core to involve then theories, they call it, I think, quantum duality. Theories that have different classical limits, but they are sort of equivalent at the quantum level, and those theories presumably would have different classical limits. And that would sort of be a straightforward case where you have this sort of distinction between two different classical limits that then stuff like perturbation theory, depending on what theory you're playing with, around, but then you have sort of a unique common core theory that tells you sort of what the fundamental picture of the duality is. Like, I think the simplest example that they play with to show stuff like this is stuff like Fourier duality in quantum mechanics, where they're like, I can take like a positional representation, I can take a momentum representation, then I have like the common core is supposed to be something like Hilbert space quantum mechanics, and that's just becomes just a choice of basis. So I'm sort of unsure why this lack of classical limit would be a problem for the common core, since they seem to sort of include this, and then you sort of can recover the structure of the models and everything once you have that.
Yes, I mean, yeah, that's a very good point. I may have been not sufficiently precise of what I mean is lacking here. So of course, if you just look at the spectrum, so at the quantities, let's say, so we would have a spectrum of quantities, and there is a sense in which you can identify, you can identify classicality based on that spectrum on its own, but you cannot interpret it in terms. You don't really understand how this links to a classical limit, to an effective theory in some of the classical limits. So in order to understand how you calculate things there, how this relates to calculations in an effective theory that you can connect to from that classical limit. You need to be in this model, right? You need to understand what's going on, so to say. So in that sense, the different classical limits, in the sense that they correspond to different effective string theories that then relate to different effective quantum field theories, that's not contained here. That's what you do not understand. You don't know what to do with it, so to say, before you go to one of the theories. And the fact that there are those dual theories that you can select here, and each of those dual theories characterizes a different classical limit, is crucial for understanding the structure of the theory. So that is the point. You first, I think I forgot your very first question.
No, I was just wondering if you could just take the first two problems that you mentioned and just reduce them to the difficulty of understanding what the classical limit means. Because once you have a classical limit, then you can understand what observation is, also in the common core. But I'm not sure I understand the question regarding the classical limit. The answer regarding the classical limit. Because
well, wherever you are in the common core characterization, you need to add the model in order to understand what's happening. You need to have a model to understand, to extract predictions from the theory, to understand how the dynamics can be extracted from the structure of the model. Now, of course, in a very positivist way, you can say it is, in a sense, it is all contained there, because all the observational surface is there in the common core, right? So if you just look at the values, you say, yes, they are all there, and the dynamics is there, that's in the definition. But you don't know what to do with it before you choose a model. You don't know if you are at a certain stage and you ask the question, okay, is that and that given our current observational data, let's say, let's assume we have some observational data about that can be linked to the theory. Given that observational data, is that and that or that trajectory a possible trajectory based on that theory? You may say, okay, sure, if some God-given theory comes down to me and tells me, well, those are the dynamics, then I can read it off. It would be a little bit like data mining from God's perspective, right? So in that sense, everything is there. But if you want to use a theory to make predictions and to understand how predictions are linked to the structure of the theory, you need to go down to the level of the model. And that is the point, basically.
Joanna, please.
Okay, thank you. Actually, to some extent, you already answered my question, because I was going to ask whether we really lose the information about the web of dualities when we focus only on the common core, or we only kind of psychologically lose sight of them. And I was considering the analogy to geometry, when you can focus either on invariance or on symmetries, which are transformation with those invariants. And you can, basically, if you have one, you can, the information about the other is encoded and can be reconstructed. And as I understand, your answer would be that the information is in the common core, so maybe I will just press it a little bit more to say whether it's like, you say we need to invoke models. Is that need related only to our cognitive limitations, kind of a psychological thing, or there is something like more objective in that need of invoking models?
I would think it's not a psychological issue. It's an issue about the content of what is identified as a common core, and the role played by the models. Of course, that's also the way one happens to, in reality, or let's say in actual science, extract predictions. So it is, but it's not. It's more than that, right? If you compare it to a situation in quantum field theory, you might say, okay, there is the full quantum field theory, and then you need a perturbative approach in order to do calculations. And then you would say, sure, we do need the perturbative approach in order to do something with the theory, but everything is there in the full characterization of the theory. But there is a difference. We try to argue between those two contexts, and the difference being that the perturbative theory follows from the full formulation of the theory. So if you have the full formulation of the theory, you find the perturbative formulation, and you find reasons why the perturbative formulation is a good approximation to that theory. So it kind of follows from there. While if I just look at the common core and forgot everything about any model, and someone would just give me the common core and tell me, okay, so tell me what the theory is. I cannot extract it from the common core. I mean, I might be very clever and come up with a model and say, look, I found a model. That's what that fits this, right? In principle, that's possible, but I cannot extract it from the common core. So it's just not. It's not enough. If you give me the common core, you haven't given me enough to spell out what the theory is. That would be our understanding.
Sam.
Yeah, I'm just wondering about this idea that these two things come apart in fundamental string theory. I just wondering if you could say a little bit more about that. Is the thought that I think it's about two in particular, the idea of this ontology relating to observation. Is the idea that we're not ever going to be able to get any kind of observational access to the high energy scales that might be relevant for fundamental string theory, and so these two things will never come together in the way they come together in the low energy case? I'm just not clear why they come apart in this sort of principled way. I wonder if you could tell me a bit about that.
It would not imply that there is no way to extract empirical signatures that point at characteristics of the deep quantum regime. It's just that we need a neoclassical entry point to make those experiments.
Yeah, I guess I'm wondering why that's the case.
So if we set up an experiment,
Yeah.
We need to set up an experiment in an environment where we have localization, where we can observe a pointer, see where the pointer points to, and those very primitive things. So therefore, I need an environment where there is sufficient neoclassical characteristics to have all that. That's the idea. Which does not mean that there is no way of extracting characteristics, parameter values that then characterize the full theory.
So it's all the sort of phenomenology is going to be happening at the neoclassical level. So you're not going to have any phenomenology happen. So any data you gather has to be sort of in the neoclassical regime.
Right. So to have a comparison, I mean, we do get information about empirical information about strongly coupled regimes, right? We can do QCD experiments, and we can do calculations there, and so on. But if we lived in a world that was strongly coupled, I don't know how we could set up an experiment that makes those measurements. That's the difference.
I see. Okay, thanks.
Thanks, Richard. It's very good. So maybe the first point I want to raise was related to what Emilia said earlier. I mean, I think it's also I think a very important point you make, which is to distinguish that in order to understand what is going on here at the ontological level and in terms of realism, it's important to distinguish dualities from gauge symmetries. They are two very different things. And in fact, on the one hand, I would like to ask you to spell out the same distinction in a simpler context, which is just the electromagnetic duality. The electromagnetic duality. I mean, there we have a duality between the electromagnetic, the electric, and the magnetic field description of the system, and it's not a gauge symmetry. On top of that, we have a gauge symmetry, which plays a very different role, and we normally wouldn't say that because the electric and the magnetic description are related by duality, they are not real, they don't give information about the ontology of the system, and we have to go to some common core. I mean, the electric field exists in any sense I can think of, and so the magnetic one, it's just that there are two different descriptions, equally real, adapted to different contexts, different contextual elements. And so I think it is misleading to try to infer what's going on in the case of dualities from, I don't know, coordinate transformations or Gibbs fields in the gravitational case or other gauge symmetries in other contexts. So first of all, I would like to know if you agree with this, and if the same story that you made in relation to string theory, in fact, can be made already at the level of the electromagnetism.
Yes. Shall I respond immediately, or do you want to?
As you prefer.
I mean, I can directly say yes. I fully.
You allow me to add a couple more questions.
I fully agree with that. One point I might want to add is that there is a distinction that has some significance here between self-dual situations and dualities that actually lead to a different kind of theory. So once you don't have a self-dual situation, the situation becomes more complicated, and it may be more, let's say, it may be more pressing to search, if you have the ontological perspective that you want to identify an ontology of, that you can be committed to as a realist, there may be a more pressing need for searching for a common core in such situations than in self-dual situations. That was something. Yeah.
And then maybe the other point is that in the case of string dualities, the perturbative versus non-perturbative aspect is an important one, which is not in the electromagnetic duality, and this refers to the last point you also made now in the reply. And I think it should be understood in the spirit of condensed matter physics, in which you have some very fundamental description of the system in terms of the atoms and so on, but then you can choose specific vacua on top of which you have excitations. And it so happens, and that's remarkable, that two different choices of vacua, and so two different set of effective perturbative excitations are still related by duality. And so there is a sort of a multi-level description. There is a fundamental common core, maybe, then there is two different effective descriptions and a duality between them. And indeed, what you're suggesting is what in the condensed matter context I would call something like a multi-level ontology. I mean, there is an ontology you can associate to the fundamental entities. There is an ontology associated to the effective quasi-particle descriptions. But I think it would be entirely misleading to only attribute ontological status to the fundamental ones and claim that the quasi-particles are not real somehow. Or, molecules and a fluid. I mean, a river exists now. I don't know. Under any definition I can think of having ontological status, a river exists.
Yeah.
although it's an effective description of something else from the point of view of our models. Again, would you agree with this?
I absolutely agree. I might add one aspect to this, and that's the connection between these several vacua of the fundamental theory, and then the tower of effective theories that connects to each of those vacua. And in a way, the way I would understand this proposal of separating the ontology from realism at the fundamental level is a way of connecting fundamental realism to effective realism, because the ontology then, in some sense, if the conditions are right, I mean, if there is a uniquely specifiable, in some sense, ground state or a neoclassical limit, in the effective theories, then what happens is that the ontology actually may play two roles, right? It may, on the one hand, characterize the vacuum structure of the fundamental theory, and on the other hand, kind of is the end point of this tower of ontologies of the ontologies of the tower of effective theories. So it makes, from this perspective, a lot of sense, or it may be very suggestive on this account to endorse a form of effective realism with respect to those low energy theories, because then what happens is that the ontologies then play the role of the focal point of realist commitment in those effective theories, and then that would be scale dependent.
Then just one very minor point in which I don't know if I disagree or I haven't understood is the relevance of the classical limit, because from the description we just seem to have agreed on. What is really relevant is the fact that you choose different vacua, and different effective field theories and different level of description. But the fact that within one effective field theory you also can take a classical limit and have a purely classical description, to me seems pretty relevant from the ontological point of view, because the ontology doesn't change with the classical limit. It's the same fundamental entities at that effective level that behave quantum or classical depending on the observables you look at. I understand the practical purpose, that in the classical limit everything is clearer and simpler. But from the ontological point of view, I wouldn't really see why it's necessary at all to look at the classical regime of the effective field theory.
Well, once again, it may make sense to separate the issue of the different dualities and from the issue of the new classical limit. So I think we are absolutely in agreement that what is happening when choosing the ontology of type of string theory, let's say, that's not necessarily, let's say not necessarily, but maybe not, about just focusing on the classical limit, because we are looking at the full theory. That's this one point where I don't have a clear understanding of where to lean to. So that's the one on the one hand. On the other hand, of course, I may have, if I think about, and then there are those discussions about ontologies at the level of quantum field theories, and in a nutshell, one divisive element in these discussions to me seems to be that some of those ontologies are more focused on the starting point of a low energy perturbative characterization, and then the opponents say, okay, but that's only the perturbative regime, there are no perturbative effects, and then your ontology doesn't make sense when you want to cover that, while others so abstain from that. Now, Yes, but I mean, it may be that in these discussions, if one focuses on the role of ontology along the lines I propose, that those suggestions that take the neoclassical limit as a starting point for building up their ontology may be more plausible. Of course, it goes through, right? I mean, it can cover the full theory. It just may seem, from another perspective, to be a little bit besides the point, to, let's say, to ontologize excitations.
You didn't have to do it. Baptiste actually has a good question.
Okay.
Can I do that?
Okay. Yeah, so the question is about, so when you want to build, so you have different possible ontological interpretation of what's happening when you have duality between theories and duality between models. So one is a common core. Another one is to break the equivalence and to have a discriminatory approach and to pick one. But you have an interesting hybrid view defended by Johansson and Keitumba Subaru and Johansson, where you say, okay, at the fundamental level you have this common core view, but you still think that you will have at the emergent level of when you get to generativity, or maybe what you call ontology, it might be that the effective description is more similar to one of the two models. So I think to combine some aspects of a common core and of discriminatory approach, and I was wondering how would you contrast your position with this kind of view, because it seems to be a bit like you said, like you use the emergent level to go down and say that one side is more important, but you still recognize, because of this common core feature, that the whole space of the theory, the level of the theory is important as well, something you insisted on. So I was wondering whether you know this paper, and if you, how would you,
So I mean, if I understand what they want to do correctly, it seems to be as you say, it's kind of a hybrid approach that uses what I would call that in some sense links what I would call this neoclassical situation that can also link to low energies. They use that as an effect, in a way, as an effective theory already, and they say, okay, so along in the spirit of effective realism, even though they don't say it that way, we might take seriously an ontology in that corner, so to say. I think that the main difference between what they are doing there and what we suggest here is that our focus is on the full theory. So the main point is how to understand the full theory. So the point is not that we need to. I mean, that's then so to say a second step that we say. And by the way, these models indicate the neoclassical limits. So in those neoclassical limits, then we can have the ontology. So the ontology part may be to some extent in line with what they suggest. The point that realist commitment is separated from the ontology not by focusing on the specific ontology of one of the duals, not by focusing on the common core, but including not having any ontological commitment at all, but including all the aspects of the theory that we need to calculate the theory. I think that's different.
Yeah, so basically the commitment to an ontological would be optional, not necessary in your view.
Yeah.
So maybe you have some aspect of what James and I call a kind of plurality view or fragmentalist view, where you acknowledge that that's part of the theory, that you have different models that are related by different relations. So your view is more texture in a way that you borrow different aspects of all those different approaches.
I think the difference is that on our account, the ontology stops to be helpful once one leaves those neoclassical limits.
Yeah.
And once one leaves them, one needs to have a different basis for realist commitment. And that realist commitment would be more would include knowledge about the knowledge.
Is that just
or statements about the models.
Is that just a semantic debate, or is it more than just saying that we will just use the word ontology for the derivative level, and at the fundamental level just talk about realism, not ontological realism, or something? Because
I think it's more than a semantic debate, because it's about what we want to what we want realist commitment to give us, so to say. So formally, we don't claim that a common core realism is not a consistent position. So you can be common core realists about that. What we emphasize, or what we try to emphasize, is that having that perspective does not give us all we would want to have from realist commitment. And in order to have that, we need a broader concept. We need to include more in what is covered by our realist commitment, and to include that is not consistent with specifying an ontology. That's roughly that's the upshot, so to say. So therefore, and then we say, okay, but ontology nevertheless is important, but it's important for different reasons. And then we go towards this neoclassical limit.
So since we started a few minutes late, I'd suggest we stop at 35, so we still have 7 minutes and 3 questions. How would you like?
Yeah, thanks. So, thanks. Thanks, Richard. This was great. You put me and Chris up there, and I don't know how much you thought you were disagreeing with us, but I think I actually kind of agree very much with most of what you sort of said here. I think relative to what we've said, and you made this comment just to Daniele, we very much focus on the sort of self-dual T-duality case,
right,
which I think is misleading for the
exactly
reasons you've
exactly
said,
yes.
and I think sort of accept that. That's fair enough. I think the one thing I maybe disagree is at the meta level, something like how much people really cared about ontology, like in the first place. I have very little trouble saying, it's about realism. I don't like approximate truth, but that aside, the ontology was never sort of a big thing anyway. In particular, it's not quite clear, in the Harrow and Butterfield, when they try to say more specifically what the common core is, that there's much ontological commitment just by that framework. Like, there could be lots of different kind of mathematical symmetries that sort of look like different ontologies, but you didn't take seriously as So I don't know, I'm not sure how much what you've done is sort of clarify this point, or kind of disagree with you on this point about the significance of ontology.
Yes, I fully agree. I don't think that ontology needs to be at the center. It seems fairly clear at the center of realist commitment. That is, it seems fairly clear that in the Harrow Butterfield they do. That's their starting point. They do want to have a universal concept of common core that allows them to have one ontology and be realistically committed to that. So that's also why we chose their formulation as a foil for characterizing what we're doing, because in their case it's very clear. It seems to us what the way they set it up and the way they actually focus on ontology. I agree that I would when trying to understand Chris and your position on this, I was not always entirely sure how important the common core ontology was for you. So you have those qualifications that indicate that you're not entirely satisfied with the de Haro-Butterfield approach. On the other hand, you quite strongly stress the common core in your account. So you seem to
well,
have.
I think, the use we really make of it is sort of a negative use, not to say what there is, but to say what isn't the case. I think. So that's why we kind of get to end up being sort of ambiguous about that.
And of course, I absolutely agree that in the case in the bosonic T-duality in the bosonic string theory case that you use to characterize the situation. Of course, there the common core perspective works better, let's say, than in other contexts. So there, if you go to other contexts, it's more difficult to sustain that. Yes.
Okay. It seems to me that you presuppose that we either have a common core strategy, or we have the type of ontological anti-realism you advocate for. But I worry that it might be a false choice you're giving us.
I wouldn't call it ontological anti-realism. I would call it non-ontological realism.
Non-ontological realism. Okay. There is a tradition, because we have science, work about theoretical equivalence that goes back roughly to Poincaré, Reichenbach, Quine, Putnam, Glimmer, Halvorson, Barrett. And one strand of that tradition says the following: you can have theories which are logically incompatible, which seem on the surface incompatible, but they are not. So it may be the case they're just using words to refer to different things. Maybe what the T-dual theories refer by radius is not the same thing. What they refer by dimension is a different thing, and so on. Take just Poincaré's famous example of how you interpret hyperbolic geometry in Euclidean geometry. You take the disk, and if you mean by line, you mean an arc. If you mean by distance and congruence, some hyperbolic, some construct of the length and so on, you get the Euclidean geometry. If you take the examples in which you pointed to disk and you ask me, is this an example of Euclidean geometry or hyperbolic geometry? It's a silly question. It is both, just on slightly different meanings of line, congruence, and so on.
Right. I don't think I disagree with anything you say. It's also, I mean, one point that is important to emphasize here is that given that those are, even if you just state that those dual theories, they are empirically equivalent. So, which means that you just need one of them to spell out what the theory is, right? So then you can identify the duals, you can find them or you cannot find them, but in order to spell out what the theory is, you just need one, right? So there is a sense in which you say if you have one model, then you have pointed at the theory, and you can say you are a realist about that. Now that is already substantially more than, let's say, the de Haro-Butterfield common core account, right? Where you don't have that. Now, what I wanted to emphasize is that understanding the fact that there is this duality structure seems to be so essential about the theory, and it also seems to be so important with respect to understanding its implications, and it is not, it cannot be extracted from the one formulation of the theory. You need to have maybe there is an understanding, there is a more exhaustive understanding of string theory that actually tells you that. But no one has found this, right? So if you use one of the types of string theory as the entry point, you only learn about the duality structure by finding the dual theories. Therefore, I find it even focusing on this one type of string theory and say, okay, I'm realist about that. In a way, that's fine, but it still omits something important about that theory. Whether you want to say that, okay, it's important, but you don't need to extend realist commitment to that. I don't know. It's a matter of that is a matter of definition. Maybe I agree.
Great. I think we should take a break now. You're on biology one. And yeah, please join me in thanking Richard and Emilia.